Hi everyone. In today's lesson, we're going to talk about graphs of parabolas in an equation called modified vertex form. So we can define a parabola as the set of all points in a plane that are equidistant from the focus point and a directrix line. So this is a parabola, right? We know it's curvy, looks like a U, or it could look like an upside down U. So each of these points on this parabola that make up the parabola are equidistant or the same distance from the focus. So let's say this point is the same distance from the focus as it is to this directrix line. So this point is the same distance from the focus as it is to the directrix line, so on and so on. That's the textbook definition. We're never going to really use that too much in class, but we're going to need to know how to apply it. So let's talk about the different forms of a parabola. So what you're used to so far is standard form. So standard form is y equals ax squared plus bx plus c. So an example of that would be y equals 3x squared minus 2x plus 7. So what we're going to work on today is a different form of a parabola or a quadratic. That form is called modified vertex form. And here's the equation. It's x minus h squared equals 4p y minus k. So this is your new equation for a parabola, where h comma k is our vertex, and p is the distance from the vertex to the directrix, or from the focus to the vertex. So take a couple minutes. If you need to pause the video to write that down, please do so. And then I'm going to talk about what this means graphically. All right, so we have two scenarios. We either have a happy parabola or we have a sad parabola. So if we have a happy parabola, the parabola is going up like such. Well, we need to know the main components. Well, the vertex is always the turning point of the parabola. So whether the parabola is opening up or opening down, the vertex is still the turning point. So in this case, the turning point is at the bottom, and in this case, the turning point is at the top. Now, the definition of a parabola states that there'll be a directrix and a focus. So the focus is always inside the opening of the parabola. So in this case, inside is right here, and inside here, the second case, is here. And then last but not least, the location of the directrix is underneath the vertex, or in this case, above the vertex. So these are the two pictures that you need to have memorized. If we have a happy parabola, the vertex is at the bottom, the turning point. The focus is always on the inside, and the directrix is completely beneath the whole parabola. Now, in the second scenario, the directrix is completely above the whole parabola, the vertex is the turning point, and the focus is entirely inside. So we need to talk about the definition. We said every point on the parabola was equidistant. So since they're equidistant, that helps us with the p-value. So the distance from here to here is p, and the distance from here to here is p. So what that tells us is that the vertex is right in the middle. And then same thing over here. The distance from here to here is p, and the distance from here to here is p. So these two pictures, we kind of need to make sure we know. All right, let's put them into perspective now. So example number 1 says we're going to identify the vertex, focus, and the equation of the directrix, and then we're going to graph the parabola. So we have an equation that's in modified vertex form, but now we have numbers. So I'm going to write the modified vertex form underneath it. So we have x minus h squared equals 4p y minus k. And now we're going to compare what we know. Well, the first thing that pops out into my head is that this 12 has taken the place of 4p. So you want to ask yourself, 4 times what gives me 12? So the answer should be 3. If it's not so easy to see, you can do a quick solve. 12 must equal 4p, and we can divide by 4, and p is equal to 3. So you actually can get a lot of information from p being positive. So since p is positive, we have a picture like our first one on the page previous, where the parabola opens upward. And the vertex is the turning point of the parabola, the focus is on the inside, and the directrix is completely below. And remember, the p-value is the distance from the vertex to the directrix, or the focus to the vertex. So that's a lot of information from one value. Now we need to find our equation of our vertex. We know that the h and the k will give us our vertex. So there's a -2 and a +1. So see how it says x minus h, and then y minus k, and then this is y plus k? All that we have to do to find the equation or the coordinates of the vertex is switching the signs of the values. So -2 will actually become +2, and +1 will actually become -1. So you can write to find the vertex that you are going to switch the signs from the equation. And I'll explain more about why that makes sense in class tomorrow. So now we're ready to graph so that we can find our focus and our directrix. So I'm going to first start by graphing the vertex. The vertex is at 2, -1. So I'm going to go ahead and plot that point and put a V for vertex. Now we know that from the vertex, the focus is p units above, and we know that the directrix is p units below. So since p is 3, we're going to go up 3 and put a dot. And then we're going to go down 3 and put a dot. Now, like we said, the directrix is completely below. So we're going to go ahead and put a straight line here. And we're going to label this with my directrix. And we know that 3 spots above is my focus. So I'm going to label this with an F for focus. So we know that my parabola would actually go this way, right? Now, to be more exact, there is another definition that we could do. Since p is 3, we can actually double that, which would be 6, right? 3 times 2 is 6. And we're going to go 6 units from the focus. 1, 2, 3, 4, 5, 6. And 6 units to the left of the focus. 1, 2, 3, 4, 5, 6. So the definition says that the distance from the focus to a point on the parabola is 2 times p. Same thing here, 2 times p, which is 6 if p is 3. So we can create our parabola equation through our vertex and those 2 points. Now, the reason why that this is 6 and this is 6 is because it follows the definition of the parabola, that any point, let's say this point, on the parabola is equidistant from the focus and the directrix. So if you notice, this is 6 units here and here, and this is 6 units from here to here, right? 6 this way, 6 this way. So it's kind of like a little trick because not all of the points are going to be like perpendicular like that, meaning like it creates a right angle so you could easily count, right? But those right angle ones are found by taking 2p. And that follows the directions that this has to be equidistant from the focus and the directrix. All right, so now we can finally answer the question. We already have the vertex. We need the focus and the direction, the equation of the directrix. So the focus is this point right here, which seems to be 2, 2. And the equation of the directrix is this horizontal line that goes through y equals -4. So we will just call that y equals -4. That's how we write the equations of horizontal lines. We just write y equals and then the y value that it goes through. All right, let's try another one. Hopefully it'll make a little bit more sense. All right, so same thing. First things first, I'm going to write the equation. X minus h squared equals 4p y minus k. So we're going to analyze first that -8 has taken the place of 4p. So you want to ask yourself, 4 times what gives me -8? So you should be thinking -2, but if you're not sure, you can just set them equal. -8 must equal 4p, divide by 4, and p is equal to -2. So since p is negative, we have a lot of information from that. We know that the parabola must go down, open downward. The turning point is always my vertex. Inside the parabola is always my focus. And now entirely above it this time is my directrix, or my equation of my directrix. So that's a lot of information from one value. Now we can find the vertex by analyzing the values inside the parentheses. So remember, to find the vertex, we're going to switch the signs from the original equation. So switch the signs. So positive 3 becomes -3. So -3. And then -2 becomes +2. So now that we have all this information, we can actually go ahead and graph. So my vertex is -3, 2. So I'm going to plot that with a V. Now, since my p-value is negative, we need to draw the situation this way. So we know that the distance from the vertex to the directrix is p, and the distance from the vertex to the focus is also p. So since p is -2, you can disregard the negative. The negative really just told us that we were going down. So we're going to go up 2 and down 2, similarly like we did before. So we're going to go up 2 values, and then we're going to go down 2 values. Now, since we have this scenario, this dot actually now is the directrix. So this dot's going to go all the way down and create an equation of my directrix. And this dot down here has to be my focus because it has to be inside the parabola. Now, like we learned before, we can double the p-value. So since p is 2, we can double that and make 4. And we can go 4 values from the vertex, the focus, 4 values to the left, 4 values to the right. And we can connect from my vertex, and that's the equation of my parabola. So again, this distance from here to here is 2p. This distance from here to here is 2p. This is your p, and this is your p. And that's my equation. So now we can answer the problem. So we have our focus, and we have our equation of our directrix. So our focus is this point right here, which seems to be -3, 0. And the equation of the directrix is this horizontal line that passes through the line y equals 4. So that is the equation of our directrix. All right, that's it for today. I know it was a little challenging, but the goal is really that you understand what these two pictures look like, and we'll take it from there tomorrow. All right, have a great night.